week's lecture, and we will continue from the part that we were talking at the end of last week. If you remember our last week's lecture, the last minutes, we were actually talking about an implicit assumption to be able to talk about consumer preferences in terms of microeconomics. And that implicit assumption was more is better assumption, okay? More is better, okay? So what does more is better mean? I actually talked about it, but I will recall the things that we talked. Actually, more is better assumption is assuming more of any particular good in the bundle and this part is important, and no less the other goods is preferred to the previous bundle. We had an example. Suppose that we have a bundle called X1, okay? Our first bundle is, let's say, 3 pizzas and let's say 4 salads, okay? And our second bundle is, let's say, 5 pizzas and 4 salads. More is better assumption here. We said that it is an implicit assumption because with this assumption we will be able to draw indifference curves, okay? According to this assumption, X2 bundle is going to be preferred to X1 bundle because as you see, one particular good here, it's pizza, more of this pizza and no less of salads will be always preferred to the previous bundle. So one individual is going to choose always X2 according to this assumption. Of course, there are some situations, there are some individuals that who will not prefer X2 over X1, but this assumption says it's going to be like this. So in this case, X2 is going to be preferred to X1, okay? More is better assumption requires this. But please do not forget that this is just an assumption, but in real life, it's not always true, okay? Why do we use this assumption? Because only with this assumption we are going to use maths. We are going to be able to use maths, okay? So we need this assumption. So let's see what are we going to do with this assumption when we are talking about preferences on a XY plane, okay, XY plane. So what does more is better assumption mean when we are talking about a function, okay? So let's make an example here. Example. Suppose that we have 2 goods. Suppose we have 2 goods. 2 goods. This is 2, by the way. 2 goods. So here our n is 2 in our example. And we have a bundle here. We have a bundle, and our bundle consists of X star, Y star, okay? So let's draw a graph to show our bundle, okay? I'm going to show you a graph. Maybe I will have to draw it big to be able to explain it well. Let's say that we have 2 goods. One of the goods, let's say it is chips, okay? And here we have, let's say, Coke, okay, a drink. So these axes, x-axis and y-axis, show us the quantities of the goods, okay? So on the x-axis, we will have the quantities of cans of Coke, let's say, and on the y-axis, we will have the quantities of maybe plates of chips, okay? So this is y-axis, this is y-axis, and this is, x-axis. So we have a bundle here. It's represented by X star and Y star. So here we have a Y. Let's say it to be Y star. And we have an X here, X star. These can be any quantities that are chosen on X and Y axes. And let's show the points of the combination in this graph. It is somewhere here, okay? It's our bundle. So to understand more is better assumption, let's divide our graph into some quadrants, okay? Let's divide our graph into some quadrants. So let's divide it. I'm not sure if I will be able to draw it like I'm drawing it on the board. Let's divide it into quadrants, okay? So we have 4 parts, and at the intersection point of these 4 quadrants, okay, we have our bundle. This is our bundle. Let's give that bundle a point. Let's say it's not B, but let's say it E, okay? This is point E. Point E represents our bundle. Our bundle of X star, Y star. Okay, let's choose another point in one of these quadrants, okay? Let's choose another point. For example, let's choose a point here. Let's call this point A, okay? Let's choose another point here somewhere. Let this point be B point. Let's choose a point on C, okay? Now let's have a look at these points. Will these points will be preferred to our bundle or not? Okay, we will be looking at this. If we look at point A, let's look where it goes when we join this point A with y-axis, let's call this point YA, okay? And let's look what it corresponds on the x-axis. By the way, let's delete this and write it smaller. This was x star, okay, x star. And here, let's call it XA. As you see, we are talking about point A. Let's write here, first thing, we are talking about point A. Point A, okay. As you see, point A is XA by A. It's the representation in forms of mathematics. Let's look to the quantities of XA and YA is corresponding to. As you see, XA is bigger than X star, okay? And YA is bigger than Y star. If we have more is better assumption, we were at point E, okay? As you see, the consumer is going to prefer point A to point E because it has more of the two goods, okay? So, for any point in this quadrant, I'm going to make it, if I can do it, okay? As you see, I'm shading. This part of the quadrants will actually provide either more of one good or the other good, or this bundle, this set of bundles, this shaded area will contain, let's write to make it clear, okay, red shaded area, let's write red shaded area. It is the set of bundles. Each point in the shaded, red shaded area represents one bundle. So the red shaded area in total is the set of all bundles, is the set of all points, which contain either more of X or Y, okay, or they contain more of both goods, okay, more of both goods. More of both goods. For example, point B. Let's look to point B, okay? So point A is an element of red shaded area. Also, I'm going to shade it like this also to contain all the points, okay? Even the points on the quadrants lines are included because let's have a look. Let's have a look to point B. Point B. Let's look. I'm going to choose another color, okay? Point B is, let's look. it is corresponding to this point, okay? So it is XB, and point B is, as you see, when we join it with the y-axis, it is equal to y star, so it is equal to YB. So we can write point B as XB, YB, okay? As you see, XB is greater than our X star, YB is equal to our Y star. If you remember the definition of more is better assumption, if only one good is more and the other is no less, the consumer is going to prefer the bundle to the previous one, okay? So as you see, of course, if two of the particular goods are more, it's much more better. But what is important here is we shouldn't have any bundle which contain less than any other good, okay? So we have here at point B, one of the goods, X good, is more than our first bundle, X star, but the other is equal to our first bundle, so it will again be preferred, okay? Because X good is more in this bundle, Y good is no less than Y star, our bundle, so point B is again going to be preferred. Point B will be preferred. Actually, point B, the bundle that is represented by point B. Bundle represented by point B will be preferred to our X star, Y star bundle, okay? The same thing is valid with the point C. Let's look to point C. I'm going to choose another color. Okay, let's choose this. Sorry. Let's choose, for example, which color? Blue, okay. Point C is on here, okay. The corresponding points on y-axis is here, okay. Let's say it YC, and the corresponding point of point C, this is point C, is equal to our X star. It's also XC. As you see here again, we have more of one of the goods, it's good Y, more chips in this bundle, but it is equal to the quantity of Coke in our first bundle. So XC is equal to X star, but as you see, one of the goods is more than our first bundle, so point C is also going to be preferred to our bundle, to our point E. Actually, this is, point E. So let's write here, point C, XC is equal to X star, but YC is bigger than Y star. Again, XC, YC will be preferred to X star, Y star. That's why I shaded the whole area here, so we will have preferred bundles here, okay? We will have all points, we will have lots of points here showing us different combinations of chips and Coke, but we are sure that all of these points will be preferred to our first bundle, which was equal to point E. So on the upwards right side of the graph, okay, will be preferred side, okay, preferred area, preferred to point E, okay. I hope you understood the logic. So let's choose another point in another quadrant with another color, actually, with this color. Let's choose point D here, okay? Point D. Let's have a look at the combination that point D is representing. This is point D's chips quantity, and this is point D's coke quantity, actually. And here we have X star, you know, our first bundle. As you see, the coke quantity at point D and also the chips quantity at point D is less than our first bundle. So if we have more is better assumption, okay, no individual is going to prefer point D and the combination and the bundle that point D is representing to our X star Y star bundle, which is represented by point E. So I'm going to shade this area. I'm trying to find a good color. Let's make it yellow, okay. So every point here on this area is worse than our first bundle. So I'm writing here yellow shaded area and all bundles in this part are worse than our bundle X star Y star. So it will not be preferred. We can write this as a preference relationship. Our X star Y star will be preferred, at least as good as, or it will be preferred to point E. It is XD, YD on the graph, okay? So this is point E. This is point E, and the other one is point D. This is point E. And this is point D. What about the other two quadrants? What do you think? Maybe we should draw the graph again because we cannot see things good. Let's choose one more color, okay? Again, I'm going to draw. Here we have chips, and here we have coke, okay? And we have a bundle at first, Y star and X star, okay? We are dividing the graph into 4 quadrants, okay? Sorry about my ugly drawing. These are lines, at least they should be. Okay, so we said that this part is worse than our bundle. This part is preferred. Okay, what about this part? Let's choose a bundle here, okay, to be able to talk about, let's choose, let's say this point, let's say point F, okay. At this point, we have, let's say, YF, okay. Let's come to the x-axis, and this is XF, okay. So point F, at point F, as you see, YF is greater than our Y star, okay, but XF is smaller than what? X star. As you see, we have some points and we are not sure if the individual is going to choose this point. We are not sure if the individual is going to prefer this point to our first bundle, because it has actually a lot of more from Y star while it sacrifices some X. But there can be some points, so this point can be an individual's decision. But we are not sure, okay? What are we going to look at when we want to understand if the consumer is going to choose this point or not? We have to look at the utility levels that the individual gets from good Y and also good X. And maybe, I'm going to write here, the individual can choose point F combination because one of the goods is more. If he or she gives more importance to good Y. It was chips actually. So there can be one person who wants to eat more chips and who can sacrifice some of the Coke because he or she likes chips very much, much more than Coke. So this can be also compared with our bundle, okay? Because one of the goods is more, the other one is less, okay? So if the utility from consuming, okay, if the utility from consuming XF, YF combination is equal to point E combination, okay, the individual can choose this. So what I'm trying to say is here we are not talking about a preference, okay. I'm not saying that this consumer can prefer point F combination to our first bundle point E combination, which was including X star, Y star quantities. But what I'm saying is the utility or the satisfaction, let's write here, satisfaction got from point F can be equal to the utility got from point E combination. What was it? It was X star, Y star, okay? So what am I trying to say is, if the utilities that an individual gets from point F's bundle and point E's, this was point E, okay? Point E's bundle, if they are equal to each other, okay, if they are equal to each other, they can be also preferred by the individual. If an individual likes chips more than Coke, the utility that he gets from more chips and less Coke can be equal to the utility that he or she is going to take from consuming, okay, so from consuming point E combination. So there can be some other points like these in our no idea regions, which are actually going to give the same utility level to the consumer. So by increasing some of the goods consumption or goods quantity in the bundle, and by sacrificing some of the other goods combination, there are some points where the utility levels that the individual gets are equal to each other. And when we combine these points, we have a curve like this. I'm going to show this. Okay, as you see, it's a curve actually. And we call this curve indifference curve, okay? I'm going to give the definition of the indifference curve, but please understand that on every point of the indifference curve, the individual is going to get the same utility level, same happiness, same satisfaction. For example, for me, I am okay if I eat 2 plates of chips and 2 Cokes, okay? But I can also be as happy as the first choice if they give me, for example, 4 chips and 1 Coke. Or I can be happy if I'm more thirsty that day. I can be the same happy if I eat only 1 chips, okay, or only half a plate of chips and 3 Cokes, okay. So there are some points that every individual, every consumer is indifferent in choosing, because he or she is going to think that it is going to give him or her the same utility level. And if we join these parts, join these bundles, join these points, we will get a curve, and we call this curve an indifference curve. This curve is called indifference curve. As you see, our indifference curve has nothing to do with the preferred side and has nothing to do with the worst side, because you know this part of the graph, this quadrant, all the points in this quadrant are worse than our point E, okay, are worse than our point E. And all this part, okay, all the points in this part, as you see, our indifference curve is not passing through. They will be preferred. Preferred means giving more utility, okay? Giving more utility. But on indifference curve, we are only changing the quantities of goods, increasing one and decreasing the other. There's a trade-off, but all of the points are giving us the same utility. So here on point F, here at this point, the utility level of point F is the same as the utility level of this point. Utility level of the also our utility level of this point, okay? This point, there are millions of maybe points. So they are, as you see, the individual is indifferent between these combinations. He is indifferent, okay? And he is going to choose one of these points. How is he going to choose the point that he's going to consume chips and coke? You will understand it when I introduce this indifference curve graph, our budget constraint, because the prices of the chips and the price of the coke will be important in this choice. So the individual is going to decide a utility level in his or her head, and he will decide, okay, by looking at the budget constraint, which point of this indifference curve representing a particular utility level that he or she is going to choose according to the prices, okay? For example, if chips is much more cheaper than coke, then the consumer is going to choose point F because he's going to get the same utility, same happiness, same satisfaction on all of these points of the indifference curve on the orange curve, okay? On point F, chips is cheaper than coke, let's say. As you see, he can buy more chips with his limited income, and he can make an expense on coke much less. But if coke is cheaper, you will see that he's going to choose a point, for example, here he's going to drink coke more than chips. You will see this at which point the consumer is going to maximize his utility, okay, according to the budget constraint. We will see it in the utility maximization or expenditure minimization part. But at this moment, the thing that you have to know is an indifference curve is a curve actually, okay, combining all the points, all the goods combinations or all the bundles which are going to give the consumer the same utility level, okay? So I'm going to write the definition of the indifference curve here. Let's choose another. Let's write it with this, okay? Indifference curves. Indifference curve. Okay. It gives us all the bundles or combinations of goods, and as you see, these bundles are represented as points on the graph, okay? Each point has a quantity of X and a quantity of Y. It gives us all the bundles that from which the consumer gets the same utility level, okay? And we can say that the same utility level, so all the points on indifference curve on the same indifference curve. Let's write on the same. This is not some, same, okay? On the same indifference curve, gives the same utility level, same utility to consumer. And another way to say this, the consumer is indifferent between all the points on the same indifference curve. Indifference curve. So let's draw our indifference curve again on a clean graph, okay? We have xy plane. This is good x and this is good y, okay? Indifference curve is something like this, okay? And at every point on indifference curve, you know, on a curve or on a line, there are infinite numbers of points. So there are infinite numbers of combinations and infinite numbers of points that are representing these combinations. So let's say point A, point B, point C, point D, here somewhere point X, okay? Not X, point, okay, point X. Consumer is indifferent between any point on indifference curve so we will say A is indifferent, B indifferent, C indifferent, D indifferent, X, okay? So consumer is free to choose any of these, and all of these bundles are going to give the consumer the same utility level or the same happiness or the same satisfaction, okay? But if the consumer wants to get more satisfaction, what does he or she has to do, do you think? Maybe he or she has to go on a other indifference curve, which is going to give much more utility to the consumer, okay? So as you see, there are lots of, I can draw here. For example, there can be another indifference curve here, okay? As you see, but the consumer, if he or she wants any combination of goods on this new indifference curve, as you see, he or she has to increase and change all the quantities of the bundles, and this utility is another indifference curve. This indifference curve is actually giving more utility. We will talk about these indifference curves and its properties more in the second part of the lecture. I'm going to give a break. Actually, I have to drink some water. And then I will come back to be talking about more about indifference curves and its properties. Okay, see you.